Worksheet is titled Solving Quadratic Equations by Graphing. Okay, so solving quadratic equations by graphing is not the best method, but we still need to understand it. Let's take a look at this first equation. Okay, so let's pretend. See, the best method to solve a quadratic equation is what we've done in the past. What did we do in the past? We factored, we split, and we solved. So for example, if I were to factor x squared minus 5x plus 6 and set up the parenthesis x equals 0, what times what is 6? That if I combine together is negative 5. That would be a negative 6. Actually, no, that's not it. What is it? 2 times 3. Actually, negative 2 times negative 3. So you factor it, and because it's equal to 0, we're going to be able to split it and solve. So I could split it and say x minus 2 equals 0, x minus 3 equals 0, which means that when you add 2 to both sides, and you get the answer x equals 2, and on the other one, add 3 to both sides, and you get the answer x equals 3. Are you with me? So that was the old method of factoring, the old method of solving by factoring and then using the zero product property to solve by splitting and solving. That is the best method on solving quadratic equations, if they're factorable. Now, on this section, they don't want us to do this method. They want us to actually graph it. So they want you to kind of pretend that there's a y equals in front of this quadratic trinomial. And they want you to go through the motions and factor, but they want you to graph it by finding the vertex. So the vertex is a coordinate, an x and y value, and you find the x value by doing negative b over 2 times a. So that's really going to be negative parenthesis over 2 times parenthesis. And of course, you go back to your original quadratic trinomial equation and find your a values 1, your b values negative 5, your c values positive 6. So when we plug in our b and our a value into this formula, b right here, a right there, that's going to be a negative 5 for b and a positive 1 for a, which means that you're going to get positive 5 over 2. Now 5 over 2 is 2.5. So the vertex x value is 2.5. Okay, now because we have a decimal, it's probably a good idea to grab a calculator. So everybody, I want to pause the video. Go ahead and grab a calculator. So we know that the x value is 2.5. Once you have the x value, how do you find the y value? You plug it in to your x's, right? So I'm going to rewrite this equation, but instead of x squared, I'm going to put parentheses squared minus 5x, but instead of x, I'm going to put parentheses and then plus 6. So I'm going to plug in my x value of 5 halves, which is really 2.5. So put a 2.5 right there, put a 2.5 right there. And we're going to use the calculator to solve this. So you guys have calculators now. Do me a favor. What is 2.5 squared? What is 2.5 squared? In other words, 2.5 times 2.5 as a decimal. 6.25, okay. Thank you. And now go ahead and with your calculator do 5 times 2.5, Christian.
12.5.
12.5, so we really have minus 12.5, and then bring down the plus 6. So ladies and gentlemen, from here with the calculator, let's go 6.25 minus 12.5, and what do we get? Negative 0.25. Did you add the 6 to it? Yeah, okay, so if you do all of this on a calculator, you're going to get your final answer of negative 0.25, right? Okay, so the y value of our vertex is negative 0.25. It's not even negative 1, it's negative a quarter of the way down. So let's graph this vertex That's a really ugly vertex, but who cares? Let's graph it. 2.5 on the x, and then negative 0.25. So check this out. 2.5 on the x, here's the origin. 1, 2, and then halfway. That's 2.5 on the x. And then 0.25 down, the negative 0.25, that's a quarter of the way down. It's not halfway down, it's only a quarter of the way down. So this is where your vertex is going to be at. There's the vertex. After you draw the vertex, of course, you're going to draw the axis of symmetry. And I usually do a dotted line right through that vertex value. So there it is. I have my vertex. I have my axis of symmetry. And ladies and gentlemen, if I want more coordinates, what do I do?
XY table.
XY table is correct. Okay, so let's go for an XY table. Now, what number would be good to plug in? 0 for sure. Now, if I plug in 0, my output will be the C value. So going back to the original, if I plug in 0, my output will be the C value, which is 6. Okay? Now, 0, 6, that's easy to graph. That's going to be 0 on the x, 1, 2, 3, 4, 5, 6, right there. Probably should have put that in red. Let me do that in red. There it is. My vertex is down here. Okay? Now, it looks like there's my vertex, there's my point, so it's going to be a curve. But you know what? To be exact, I'm going to plug in the value of 1, all right? And I'm also going to plug in the value of 2. So check this out. Let me plug in a 1 and a 2. If I plug in a 1 into the original, plug in a 1, check it out. What's 1 squared? That's 1. 5 times 1 is 5. So I have 1 take away 5, that's negative 4. Negative 4 plus 6 is 2. So when I plug in a 1, I get out a 2. Now that's a coordinate, and if I wanted to, I could graph it already, the coordinate 1, 2. So if I'm at 1 on the x, 2 on the y, here's my coordinate. After that, I want to try and plug in 2. Just that way, see, if I plug in 1 and then I plug in 2, I'll know exactly where it's at. I want to know exactly where it's at. So if I plug in 2 into the original, please pay attention, guys. Plug in 2 right here, it's 2 squared. What's 2 squared? 4. What's 5 times 2? 10. 4 take away 10. What's 4 take away 10? Negative 6. And what is negative 6 plus 6? 0. So when I plug in a 2, I actually get out a 0. Does that make sense? Okay, so let's graph the coordinate 2, 0. So here's 0, 0. Let's go 1, 2, and 0. That's right there. So let me put a dot right there. And of course, if I want my full parabola, I'm going to reflect it on the other side of this axis of symmetry. So this one is half a unit away, so half a unit would be right there. Does that make sense? Okay. This one up here is 1 unit and a half. So let me go 1.5 units that way. There's a half, there's 1, put a dot right there. And the final one is 1 unit, 2 units and a half, so 2.5 the other way. There's half, there's 1, there's 2, put a dot right here. Okay guys, so we have this parabola. All we need to do is draw the line right through the parabola. Let me do that. Now, ladies and gentlemen, we graphed it, and what we need to understand, today's main lesson is to understand that the answers to an equation are the x-intercepts of the parabola. Let me repeat that. The answers to a quadratic equation that's set equal to 0 are actually the x-intercepts of a parabola. One more time. The answers to an equation of a quadratic trinomial that's set equal to 0 would be the x-intercepts of the parabola. So if you look at this parabola, where does it cross the x-axis? It doesn't cross at 1, it crosses at 2 and at 3. Now that's exactly why the answers to the original quadratic trinomial equation are 2 and 3, because the parabola crosses the x-axis at 2 and 3. So what I want you to walk away with this video is this. The answers to a quadratic trinomial equation set equal to 0 are the x-intercepts of the graph of that parabola. Okay? That's what we need to learn today. So, if you know how to graph a parabola, which we do know, we should know from last week, then you'll see where it crosses the x-axis, And those values of where it crosses is going to be the answer to your equation. So, ladies and gentlemen, the quickest way to do it is to factor, split, and solve. But an alternate method is to graph the parabola and find your x-intercepts.